Hello everyone. So today we're going to go over section 8.3 and 8.4, dividing integers. So we'll begin by looking at the division question 6 divided by 2. And as we know, 6 divided by 2 is equal to 3. Oops. And there are three components to any division question. The first part is the dividend. That is the number to be divided. The second part is the divisor. In this case, it is 2. It is the number that we are going to divide by. And the third part is the quotient. So that is the answer to the question. So when we divide 6 by 2, it can have two different mathematical meanings. The first one is 6 objects into 2 equal groups. And in the case that we're looking at, if there are 2 equal groups, there will be 2 equal groups of size 3. The other meaning is we have 6 objects into groups of 2 and then that will give 3 equal groups. Okay, so we are going to use both of these mathematical meanings to look at dividing integers first using counters, and then we'll look at dividing integers using a number line. So to divide integers using counter, the number of counters is going to represent the first integer, and the second integers, if it is positive, we divide into that number of groups and then count the number that is in each group. If the second integer is negative, then we divide so that each group contains that number, that integer, and then we count the number of groups. Okay. And again, using this model just gives us an idea on how dividing can kind of look. So the first one, we have 6 divided by 2. We have 6 positive counters in yellow here, and then we're going to divide it into 2 groups, and there are 3 counters in each group. So 6 divided by 2 is 3. All right, so 3 per group. Okay, next up we have very similarly negative 6 divided by positive 2, so we start with negative 6 counters. We are going to divide them into 2 groups, and that will give us, see here, each group will contain negative 3 counters. Okay, so in this case, negative 3 per group. Okay, what if the second integer is negative? Well, then we can look at something like example 3. We began with 6 negative 1 counters, and then we're going to divide by negative 2. So we're going to divide into groups of negative two negative counters. And here we'll have 3 groups. All right, so therefore negative 6 divided by negative 2 is positive 3. Okay. So one more, very similarly, we have a negative 8 divided by negative 4. We begin with negative 8, sorry, 8 negative counters. We divide it into groups of 4 negative counters each, and we will get 2 groups. So therefore, negative 8 divided by negative 4 gives us positive 2. Okay. So looking back, when we are dividing by positive integers in examples 1 and 2, we are dividing into that many groups. So positive 6 divided by positive 2 in example 1, we make groups of 3. So that's why the answer is 3. Negative 6 divided by positive 2, we divide negative 6 into 2 groups, and so each group contains negative 3. Whereas if we're dividing by negative integers, we're asking if we divide it into groups of negative 2 counters, for example, in example 3, then we have 3 equal groups. So, and it's very similar in example 4. So using counters doesn't handle a positive integer dividing by a negative integers particularly well, but we can look at other models that can help us look at what the answers could be in those cases. And that model will be the number line. So the first integer in our division questions indicate our finish point, and we'll mark it on the number line. And the second integer indicates the number of hops we took to and the direction we faced. So if the second integer is positive, we face the right, because the right side on the number line is the positive side. And if it's negative, we face the left. Okay. So the solution will give us a number of steps in each hop. If we hop forward, then the solution is positive. If we hop backwards, then solution is negative. Okay, so in order to have a better understanding, we should look at some examples. Oops, sorry about that. Okay, so if we are to model positive 8 divided by positive 4, we want to get to positive 8. And we start at 0. So since we're dividing by plus 4, we took 4 hops facing right. One, two, 3, 4, and of course the hops will be the same size. So in this case, we can see that each hop was size 2. So this would be plus 2, and it's going forwards. So 8 divided by 4 is simply 2. Now, what if we have positive 8 divided by negative 4? Okay, so our start, which is 0, and our end point, which is positive 8, are the same. But this time we are going to take 4 hops facing left. And notice that this time around we are hopping backwards. So since we're hopping backwards, each hop will be negative. So this will be -2, -2, -2, and -2. And so positive 8 divided by -4 will be -2. Okay. Now let's look at what happens if the first integer is negative. So we have -8 is our end goal. We start at 0 once again. So to get to -8, we take 4 hops facing right. And these would be backwards hops. Right, so this would be -2. So therefore, -8 divided by +4 is -2, right? Because we hop backwards 4 times, and each hop is size 2. And finally, what if both the dividend and the divisor are negative? So again, we start at 0. We are trying to get to -8. Hopping forwards this time, so going from 0 to -2, then from -2 to -4, -4 to -6, and finally -6 to -8. So these are forward hops. Right, so therefore -8 divided by -4 is going to be +2, or just 2. All right, so if we are to divide integers without using a model, this is a good way to summarize what we saw with the number line and also with the counters. The quotient of two integers with the same sign will be positive. So that would be if we take a positive integer and divide it by a positive integer, or if we take a negative integer and divide it by a negative integer, then the quotient in both those cases will be positive. Of course, on the other hand, if the quotient of two integers of different signs, then the result will be negative. So either a positive integer divided by -1, or if a negative integer is divided by +1, the result will be negative. Okay, so quickly here we have some examples. 12 divided by 4, both positive, so the result will be +3, or just 3. -36 divided by +12. Notice that the dividend and divisor are different signs, so the result here will be negative, and it will be -3. Likewise, in part C, 15 and -5 have different signs, so the quotient will be negative, so this was -3 again. And afterwards, -63 divided by -7, since both those integers are negative, the quotient will be positive, so this would be +9. 24 divided by 6, again, both of those are positive, so the result will be positive as well, +4. And in example F, we have 27 divided by -9. Since those have different signs, again, the quotient will be negative, so this is -3 again. And for the last three, we have +7. Since both the dividend and divisor are negative, we have -3. Since -51 and +17 have different signs, And for the last example, we have a multi-step question here. Again, we're going to go from left to right. So negative 24 divided by 4. Since these two have different signs, the quotient would be negative. So this will give us negative 6. And negative 6 divided by negative 6, this will give us positive 1, since the negative 6's have the same sign. Right, so, one quick example. Daria and 4 of her friends went out for lunch. They agreed to split the cost equally. The total bill came to $85. Daria paid with her credit card. How much did each of her friends owe Daria? Okay, so this is simply, since it's money being owed, so this is negative 85. There are 5 people in total, so we're going to divide by 5. So this will give us a result of negative 17. In other words, Daria's friends each owe her $17. Okay, so today we looked at dividing using counters, dividing integers using number line as well, and finally, without either of the models, what the results would be like. And that's it for today, so thank you for listening.